All right, so today we're going to talk about composite functions. Oh, yes. And so composite functions is when you put together different functions. It is related to adding or subtracting or dividing functions, but composite functions are actually a different idea where you put one function into the other function. Okay? All right, so let's look at first just the adding, subtracting, multiplying, and dividing. And then after that, we'll look at what happens when you put a function into a function. So this function, f of x, every output is just 2. So if I input 5, I get 2. If I input 7, I get 2. If I input negative 500, I get 2. This function g of x multiplies by 8 and subtracts 6. You can see there's an h of x function, and there is a j of x function. In the first one, f plus g of x, we're just adding the two functions together. So f of x is 2, and g of x is 8x minus 6. And then we'll combine like terms and get 8x minus 4. Let's look at number 4, and then I'll give you a minute to try some of these. In number 4, we're going to multiply. So we're multiplying j, which is 3x, times g, which is 8x minus 6. When we multiply the two functions, you've got to distribute. So you'll multiply to get 24x squared. And then 3x times negative 6 is negative 18x. Okay, in j minus h, a lot of you guys asked me a good question. Does that minus distribute to both, right? And it does. So it's 3x minus. To remind you to distribute it, you could put parentheses. And that reminds you that it's going to distribute to both of these. And so that's going to be a plus 8x and a minus 2. So we should get 11x minus 2. Are we good? Okay. Number 2 is a division. G of x over f of x. So g is, this says g, right? Let me know if I read things wrong because my eyes are not that good. Over f of x. All right. Raise your hand if you simplified that. Ben, what you get?
Got like 8x minus 8. Then are you still allowed to have that, or do you have to put it down?
So explain how you got that 8x minus 8 here. Okay, so you're thinking about the exponent rules, right? Okay, so when we have when we divide exponents, we subtract, but if we divide numbers, we divide, right? But help me with that, okay? Because I know you can do this. Then what did you get for 8x divided by 2? 8 divided by 2?
Oh, I'm sorry.
Good. All right, 4x minus, and then 6 divided by 2? Yeah. So 4x minus 3. Good.
I thought you were supposed to divide x too.
Because they're not like terms?
Yeah.
So for adding and subtracting, they have to be like terms. You guys, I think, are thinking you're kind of back on your exponent rules, right? Because we just did a test with exponents. But we can divide 8x by 2, just like we can multiply 8x by 2, right? It's only adding and subtracting that we can't do. Yeah. Okay. G minus h. So g is 8x minus 6 minus, and then the h, oh, we already did a minus h. That's interesting. It's going to look the same, right? Oh, it says of 2. Oh, okay. So we can simplify it first, or we can put the 2 in first. That's really up to you. So this one, we're putting 2 into the function for x. You could do that first, put it into g and put it into h and subtract, or you can get the simplified expression and then subtract. I already have it set up this way, so I'll do this. So I have 8x minus 6 plus 8x minus 2, 16x minus 8. So far, is this okay? Okay. And then we're going to put 2 for the x. So we go 16 times 2, 32 minus 8, 24. Anybody else get 24? Okay, I'm going to double check myself. Let's see. Let's look at the last division. J is, where's J? Wait, there's no J, is there?
Just 3x.
I really can't find, oh, that's J right there. Okay. 3x over f, which is 2. Does that simplify? Not really. Did anybody write 1.5x? That's fine. So you could write 1.5x, or you can leave it as 3/2 x. Sometimes some people like to put the 3/2 in front, like that, or you can put 1.5x. But really, if you didn't simplify it at all, I'd be fine with that too. All right, what questions do we have on adding, subtracting, multiplying, and dividing? Yes?
Do any of the rules we had from last time, like
Apply?
this? Yeah, apply.
Okay. So if we run into an exponent, we'll use exponent rules. Or if we run into a radical, we'll use those rules. I do expect those things to recur, but at the moment we haven't used one. I think we might get to the point where we have to square a square, and then yeah, we would be thinking about exponent rules again. Okay. Okay. So composition of functions. Here's how we might write it. We might write it g of f of x. G of f of x. It means I take that function f and I put it in to function g. We'll see how it works in just a minute. There is another way of writing it. The other way of writing it is like this, g, and then this little circle. I like to think the circle means of f, like that, g of f. You'll see that notation on the back of your notes, but sometimes we write it like this, and sometimes we write it like this, and they mean the same exact thing. What would be different is if I did f of g. F of g is different. All right, so what happens is you would put an x value into the inside function, and then you get something out, and then that number you get out goes into the next function. We're going to look at a table first, and then we'll look at some examples down here. So this table is showing us if I input -2 into f, I would get 0. If I input -2 into g, I would get 7. All right, so it's kind of showing you an input-output table for 2 different functions. Input-output for f, and then for g, same input, but different output. So to evaluate g of -2, we start with the inside. We're going to do g of -2. So you find -2 on your x, and what's the g value?
7.
It is 7, good. So this value here is 7. Now I'm going to do g of 7, the outside function. So now 7 is the input. What's the output for g? 3. All right, so we put a number into a first function, we get an output. That output becomes the input for the next function. All right, give B a try, and I'll come and see how you're doing. Remember to start on the inside. Start on the inside, start with f of 5. This one, 5 here. You see it? All right, there's the f column. Let me get out. 5, good. So that means this part here is 5, right? And then you're going to g of 5.
It's basically
Do the
I mean, it's kind of just like, you just do like, look, just get a number of -2 and just find one x column, and then basically you can just, once you get the number, you can cross
So
it
you start on the inside,
to,
you get F5, right?
and then you
So you want to find where's the F5.
whatever answer you got for that, which was 7.
So we're doing
basically
F of 5, so you're going to find the F value.
and then you basically get 3 as you
So the inside part, which is 5, and now you have 3 and 5, the right G of 5.
because yeah, you just solve it inside and use that answer.
Okay, so now you're at F5 again, but this time we're looking at G. Wait, so your teacher said that?
No, like she's an actual teacher. I don't know how she's still teaching. I've had it all these years.
I still remember.
We're not even doing algebra with tables.
I still remember this. I don't remember.
Yeah.
If I try to review that, I get to see the third, the test that I'm supposed to take, what's the third, part 1, whatever. You know what I'm talking
Yeah.
about? Can I take it on Monday? So I can do the review over the weekend.
Yeah, that's what's fine. You look for 5 in the X column, whatever. Number is in F, which is fine. Add F the answer for F.
All right. So F of 5, we looked at the 5, right? And the F value was what number? 5. Sometimes the input and output are the same. So this gave me 5. And we're doing G of 5. All right, so now I have an input of 5 again. I'm coming down here where the input is 5. And I'm looking at the G value, and that's 0. Questions on that? So it's a good question. So we already did F of 5. We did that first and we got 5 for an answer. So when we did F of 5, we got 5. And so that part's done. And so now we take our outside function. Yeah. All right. Now we're going to compose functions. So we're going to deal with x values instead of number values. Show me you're ready. I can see some of you are ready. That's good. All right. What we're going to do is we're going to take g of x and we're going to replace it for the x in f. So my outside function is f. And so I have 3. Instead of the x, I'm going to put g of x minus 2. My outside function is f. I'm writing the function f down here, but instead of the x, I'm putting g of x. Okay, so I took this one down here, replaced x with g of x. Now, g of x is an actual function. It's x squared. So my g of x becomes x squared. So I have 3x squared minus 2. So I put the function g into the function f. Has anybody ever seen them, like the nesting dolls? It's like where there's a doll inside a doll inside a doll. They're made out of wood. Yeah? It's kind of like that. We're putting a function into a function. All right, let's do f of x. We're going to put function f into function f. That's really a nesting doll because it's the same thing, right? Yes. Go ahead. Uh-huh. You want me to start over? All right, so I took my outside function f, 3x minus 2, but instead of the x, I replaced it with g of x. So I'm putting function g into function f. Why is the x separate, like right here? So function f is 3x minus 2, right? And then I just replaced 3x with g of x, the function g of x. Do you see how it just replaced it with that? I started with 3x minus 2, and then I have 3gx minus 2. Because g of x is my inside. Setting it up is the hardest part. You guys are good at simplifying. Just understanding the first step is the hard part. Yes?
If you like replace the x with the what's it? Oh wait, did you replace the x with just the g of x?
Exactly.
X squared.
Which becomes x squared. Yeah, g of x is x squared.
Oh, that kind of seems like you're doing it backwards, like the whole thing.
That's interesting. Let's try another one, okay? This time my outside function is f again, and f is 3 times something minus 2. This time my inside function is f of x. Okay, so it starts the same because outside is f for both of them. But this time I'm putting f of x in for x. Now, I'm going to replace f of x with its function. So 3 times, and what function is that? 3x minus 2, right? I'm putting 3x minus 2 into 3x minus 2. Sometimes I use a different color to show the inside function and the outside function. So my inside function is 3x minus 2, and my outside function is 3x minus 2. That's the hard part, setting it up. Then we just simplify. I'm going to multiply and then combine like terms. I saw some good starts. So we're doing g of f of x. So g of 3x minus 2. And now what we need to do is look at function g, and we replace the x with 3x minus 2. So my outside function is a squaring function, and my inside function is 3x minus 2. Okay, so I had to take 3x minus 2 and replace the x's in function g with it. The setting up is the hard part, but there is still a little bit of challenge because we have to square a binomial. Yes?
Why didn't you use like the x squared on the outside?
Use the x squared. Oh, I see what you're saying. So that's what I would have if it was a problem like on the top. On the top is we multiplied two functions together. And so then I would have x squared times 3x minus 2. But I'm not multiplying the functions. I'm putting one function into the other. So the function g says take whatever goes into that function and square it. All right, so now to square it, we're going to have to multiply it by itself. 3x minus 2 times 3x minus 2. We're kind of running out of space, but we'll make it work. All right, and then you can multiply with a box, with FOIL, with distributing, whatever you like. 3x times 3x gives me 9x squared. I get negative 6x. Another negative 6x, and a positive 4. And I'm just going to write my final answer in a different color so you can find it. So finally, I'm going to get 9x squared minus 12x plus 4. So we turn the page to the back. In the back, the setup's a little weird because there's this line here. It looks like we're dividing. We're not dividing. It's just like here's a function f and here's a function g. Okay? So we're going to evaluate based on this graph rather than based on the equations. We're going to look at the graph. To find f of 1, 1 is the input. Is input x or y? X. Good. So f is the quadratic one, g is the linear one. So this one is f, and this one, oops, f is quadratic, right? Sorry, this one is f, and the linear one is g. All right, so we're going to put 1 into f. So go to 1, and f is the quadratic, so we need to go to the quadratic function. We're right here. Do you guys see that point? So I put 1 in, and yes, I get negative 5 out. So when I put 1 into f, I get negative 5 out. All right, so I did the f of 1 part. Now I'm doing g of -5. Remember, -5 is the input. So I go where x is -5. And then I go down. What number does that look like to you? Yeah, it looks like -9 to me also. So it's kind of like following a set of clues, right? Like a scavenger hunt. Let's do another one together and then I'll let you guys do C. Yes?
How do you know which part of the rectangle that?
Oh, good. So if you didn't know for sure, you could make a table of values or something like that. But I can see that this one is quadratic because it's squared. And a quadratic function should look like a parabola. And then this one is linear. It looks like y equals mx plus b. So that should make a straight line. But if I had like two different parabolas, then I might have to either make a table of values or graph on Desmos or something like that to figure it out. All right, let's do the next one. We put -1 into g. So when I put -1 into g, I think I end up right here. Does that look like I get out -1? Yeah? Right here? So I'm doing a new problem. So when I put -1 into g, I go over to x is -1 and I get y is -1. And so then I put that answer into f. So here's f, -1, and I'm going to go down here. Looks like it's right at the vertex. So what value do I get out of function f? -9. That's interesting. Yeah, they both ended up down here. I was like, how did that happen? But they both ended up being -9. Okay, so try f of g of 0. All right, g of 0. So we had to find the place where x is 0. And we have to then find the place on that line. Okay? So g of 0 means where is the x 0? The y is what number? 1. So g of 0 is 1. So now we're going to do f of 1. Okay, now we're going to find 1 on our x-axis. And we have to go to function f, which is the parabola. So we go down. And when x is 1, y is how much? -5. So, g of f of x, our outside function is g. So I have 2 times f of x plus 1. So I put function f of x into function g. I'm not using the graph. I'm just going to use the equations. All right, so then I'm going to put function f of x in there. 2 times x squared plus 2x minus 8 plus 1. And then I just distribute the 2 and combine like terms, and we're good. And I cross this one out below, and I'm just going to continue working on this one. 2x squared plus 4x minus 15. All right, last section. So another notation for composition. This also means g of f of x. Remember on the first side of our notes, I did tell you that there were 2 ways to write g of f of x. If you see this with an open dot, it means g of x f of x. If you see it colored in, that means g times f of x. So it has to be an open dot to do g of f of x. All right, so this one we're doing a number. So what I'm going to do is I'm going to put the number into the inside function first, and then I'm going to put it into the outside function. I just want to show you that this is the other way of writing it. Like that. You don't have to write it twice. That's just like if it helps you understand it to see it that way. So I'm going to put 4 into F first. I'm going to keep the G on the outside. And when I put 4 into F, I have 4 root 4. How much is the square root of 4? 2. And 2 times 4 is 8. So I have G of 8. And now I'm going to put 8 into function G. 8 plus 3, 11. So I'm going to rewrite it just because it helps me kind of get my mind wrapped around it. You don't have to rewrite it. So I'm going to put 6 into G first. So when I put 6 into G, I have 6 plus 3, which is 9, right? So F of 6 plus 3, which is F of 9. Now I'm going to put 9 into function F. So that's going to be 4 root 9. What's the square root of 9? 3. Square root of 9 is 3. 3 times 4 is 12. Good. Questions? Okay. So h of f of x is the same as h of f of x. Like that. I'm going to start with my outside function, which is to square. I'm going to square my inside function. Okay, so my outside function says to square my inside function. And then my inside function, I'm going to replace f of x with what that is. So it's 4 root x. I'm going to just go through that again because the hard part is the setting up. And then after that, it's just some pretty straightforward simplifying. So I rewrote it. And then I took my outside function h. And I put the something squared. Replace the x with f of x. Replace f of x with what it equals. And now, what is 4 squared? What is square root of x squared? X. Yes?
I technically did it from the inside out. It still worked.
Okay.